Today we are going to talk about chemical bonding. So when we discuss chemistry, we would always encounter chemical bonds. Let us first start by a definition of what a chemical bond is. Chemical bond can be defined as an attractive force that holds two atoms together in a more complex unit. It is formed as a result of interactions between electrons found in the combining atoms. As you can see from the image on the left, you can see two hydrogen atoms. And when these two hydrogen atoms form a chemical bond, what we now have is a hydrogen molecule. Next, let us define the term ion. Ion is an atom or group of atoms that is electrically charged as a result of the loss or gain of electrons. So when we say that a substance is ionized, that means that the substance is converted into a charged particle or a charged substance. Now we have two types of ion, and the first one is the anion or the negatively charged ion. This is an atom that gains one or more electrons. So for example, on this screen, originally what we have is a neutron or an atom. On this part of the screen, you will notice that this atom has 3 protons and 3 electrons. Now, when this atom gains one more electron, it now becomes an anion or a negatively charged ion because if we will be adding all of this, it now has a negative 1 charge. So this is how an anion is generated. The next type of ion is the cation or a positively charged ion. A cation is an atom that loses one or more electrons. So here we have the neutral atom, an atom that has no charge. Once it is ionized, it loses an electron. If you will notice, we now have 2 negatively charged electrons and 3 positively charged protons. So in total, this cation will have a charge of positive 1. Ion formation requires the presence of two elements, a metal that can donate electrons and a non-metal that can accept electrons. Always remember that for a substance to become ionized, there must be a substance that has donated the electron and a substance that will accept the donated electrons. There are different types of chemical bonding. So we have divided it into two divisions, the strong ones and the weak ones. Under the strong bonds, we have the ionic bond, covalent bond, coordinate bond, and metallic bond. And under the weak bonds, we have the hydrogen bond and the van der Waals interaction. This is just one way of dividing the different types of chemical bonding. But generally, we divide chemical bonding as ionic bonding and covalent bonding, which we will discuss in the following slides. Ionic bond is a type of chemical bond characterized by the complete transfer of electrons. So here we have the sodium ion and we have here the chloride ion. Sodium has an excess of 1 electron. And chlorine, if you will see on this screen, has 7 electrons. So what will happen is that since sodium is a metal, its nature is that it would donate completely this electron. So this electron will be donated into a non-metal, which is a chloride ion. So now we will have a transfer of electrons, making sodium to have a positive 1 charge and chlorine to have a negative 1 charge. So the type of chemical bond that is formed between metals and nonmetals is what we call the ionic bond. Now, the next type of bond is the covalent bond, which is characterized by the sharing of electrons. In the previous slide, we have seen that in ionic bonding, there is a complete transfer of electrons. So sodium completely loses that one electron that it has transferred. Now, for covalent bonding, the electrons are being shared between two atoms. So here we have carbon, which is a nonmetal, and hydrogen, which is another nonmetal. So another um, factor is that in covalent bonding, it exists between nonmetals. So hydrogen has one electron in its outermost shell, and carbon has four electrons in its outermost shell. So that means carbon can form four covalent bonds, okay, with hydrogen. Hydrogen can form one covalent bond, meaning it can share this one electron, and carbon can also share one electron. So for this, these two electrons are both shared by carbon and hydrogen, forming the covalent bond. Here are some examples of substances that are formed through ionic bonding. So we have here different crystals, and we know that ionic bonding belongs to the type of chemical bonds which form strong substances. Ionic compounds has high melting points, like for example, our table salt or sodium chloride has a melting point of 800 degrees Celsius. So you need to have this temperature in order to break the ionic bonding. Another physical property of ionic compounds is that generally they are hard but brittle. Solutions of ionic compounds and melted ionic compounds conduct electricity, but solid materials do not. So for example, when we dissolve sodium chloride in water, it separates into ions. It separates into a sodium ion, which is positively charged, and a chloride ion, which is negatively charged. The reason why it is an electrolyte or it can conduct electricity. But if these substances are in their solid form, meaning they are not separated into ions, they cannot conduct electricity. Another type of bond is the metallic bond. Metallic bond is defined as the attraction of the stationary metal cations to the surrounding mobile electrons. So metallic bonds is present for the metals. Like for example, the gold metal, the silver metal, and other types of metals. Metallic bond is also responsible for the properties of metals. What are the properties of metals? Metals can conduct electricity and heat well. They are ductile and malleable, and they have luster. Another type of bond is the polar covalent bond. A covalent bond in which the electron distribution between atoms is unsymmetrical. So if you can see from this image over here, in the showing the electron density. So here we have a bigger bulge. So that means that what is being seen in here is a polar covalent bond. So the band polarity is actually due to the difference in electronegativity. So fluorine is much more electronegative compared to hydrogen. Now, what is electronegativity? Electronegativity is the ability of an atom to attract towards itself the electrons in a chemical bond. This is the polarity of a bond which is affected by electronegativity values of the atoms involved in that bond. Now, what are van der Waals forces? Van der Waals forces are the weakest intermolecular force and consists of dipole-dipole forces and dispersion forces. So these are weak interactions between molecules that involve dipoles. What are dipole-dipole forces? These are attractive forces between the positive end of one polar molecule and the negative end of another polar molecule. Polar molecules have permanent dipole-dipole interaction. So just like, for example, water molecules, they have dipole-dipole forces because water molecules are polar molecules. London dispersion forces are the weakest of all the intermolecular forces. These intermolecular forces occur between atoms and between nonpolar molecules as a result of the motion of electrons. So all nonpolar substances have London dispersion forces. Next, we have hydrogen bonding. This is an intermolecular attractive force in which a hydrogen atom that is covalently bonded to a small, highly electronegative atom is attracted to a lone pair of electrons on an atom in a neighboring molecule. Not all substances or compounds that have hydrogen has hydrogen bonding. Hydrogen bonding is only existent if there is oxygen, nitrogen, sulfur, and fluorine in your um, compound or in your molecule. Just like, for example, water. Water has hydrogen bonding.